Hello and welcome to Core 4 Revision with Mr. Quinn. Today we will be working through the June 2010 MEI Core 4 paper. I will be giving hints followed by work solutions. I would encourage you though to attempt the questions after listening to the hints, and only after this should you refer to the work solutions. Question 7. Vectors. To verify that AB is equal to this, you have two options. Either think of point A, add this on to show that you get to point B. Alternatively, show that AB is equal to minus A plus B. To write down the vector equation of the line AB, can you simplify this and combine it with get onto the line and move along the line? To then calculate the angle it makes with the vertical, think about what vertical means in terms of X, Y and Z. For part 3, think of the line as a series of coordinates x, y and z. Can you then sub them into the equation of the plane, find lambda, and then find the point of intersection? For part 4, can you find the angle between the line AB and the normal to the plane using the dot product rule? This will give you the angle between the normal and the vector. Can you then find the angle where it cuts through the layer? Now hit pause and you give it a go. Part 1. To verify that AB is equal to 300, 100, 100, we think of moving from A to B. Firstly, we move from O to A, then add on A to B. This should take us to B. OA is equal to minus 200 over 100 over 0 plus AB, which is given as 300, 100, 100. We can use this as we've only been asked to verify. This is obviously equal to 100, 200, 100. And clearly this is equal to the position vector of OB. To find the magnitude of AB, which is the length of the pipe, we find this by effectively using Pythagoras in 3 dimensions. This is equal to the square root of 100 squared plus 200 squared plus 100 squared, which is equal to 244.95 meters to the nearest centimetre. To 3, 1, 1 by dividing all 3 by 100. Here we have our vector equation of the line AB. To find the angle that this line makes with the vertical, we think of the direction of this line, which is 3, 1, 1. Then we think about the vertical. The vertical direction neither moves in X or Y, but only moves in the Z plane. This gives us a vector of 0, 0, 1. We will now use the dot product rule to find the angle between 3, 1, 1 and 0, 0, 1. As can be seen, we times the direction vectors using the dot product rule and then divide by the magnitude of each vector times the other. This simplifies to 1 over the square root of 11, which therefore taking the inverse of cosine of this, gives us theta to be equal to 72.45 degrees. To find the point of intersection of the plane and the line, which is the pipeline and the rock face, we think of the plane and the coordinates of this as being a series of x, y and z. Writing these down gives, we can now sub these in, the x value into the x value of the plane, the y value in for y, and z for z, to get this. Then simplifies to, and simplifying further gives, now that we have lambda, we can sub the 40, which is equal to lambda, back into our equation of the line, and this will give us the point of intersection. In part 4, we're trying to find the angle where the line intersects the plane. As can be seen, here's a plane with the line going through it. If we look at the normal and the angle between the line and the normal, then to find the angle we use the dot product rule. However, to find the angle which the pipeline cuts through the layer, we're actually looking for the angle here. So we can find theta and then subtract it from 90 degrees to find alpha. As you can see, we're trying to find the angle between the vectors 1, 2, 3 and 3, 1, 1. That's the normal and the direction of the line. On the top we use the dot product, and on the bottom we need to find the magnitudes. 3 squared plus 1 squared plus 1 squared gives 11. 1 squared plus 2 squared plus 3 squared gives 14. Simplifying gives us 3 times 1 plus 2 times 1 plus 3 times 1 gives us 8 over the square root of 11 times 14. Therefore, finding theta by taking the inverse of cosine, we get theta to be 49.86 degrees. Therefore, the angle with the layer is equal to 90 take away 49.86, leaving us 40.14 degrees.